Hello, everybody, irrespective of the time zone, wherever you are around the world. Welcome to this new edition of the World Federation of Neurorehabilitation webinar series. Today, we have a very intriguing topic. It's the applicability of XR, VR, AR, whatever technologies in transforming neurorehabilitation. We are very honored and pleased to do that jointly with our friends from the XR4REHAB initiative in Europe, which is a big let's say, program or structure sponsored partially by the European Community, European Union, to enhance the availability of XR technology, especially in the field of rehabilitation and medical practice in general, you like. And today we will try to give a short glimpse on what our current interesting developments in this field. I'm very much honored to do that jointly with my dear friend Remco Hoogendijk. Remco is the let's say leader of the technology or research group at St. Martin's Clinic in the Netherlands, and he is also chairing the activities of the XR4REHAB endeavors. Remco, do you want to introduce yourself shortly and tell a little bit about XR4REHAB?
Oh, well, thank you very much. I can get used to you bragging about me. That's well, very pleasing. But yes, it's true. The let's say the possibilities of new technologies such as virtual, augmented, or mixed reality are enormous and can have a huge impact on healthcare. And we are looking at those not only from a research perspective, but also from the perspective of the clinical impact. What can we actually do? How can we use this technology to promote people in their own homes, in their own habitat, to enhance their therapies and to make healthcare better? And we do that not only as a luxury, but also as a way maybe to cut costs or to work a little bit more efficient, because at least in the Western world, we do have a lack of healthcare workers, of physiotherapists or people that are able to assist. So finding out new ways is an exciting new field, and the XR4REHAB Association is studying that, discussing that, exploring that, and therefore all of your viewers and listeners are most welcome to join us on this enormous quest.
Yeah, and I should also mention, for all of you who have a deeper interest in that, go on the WFNR website. You will also find a link to the XR4REHAB initiative, and eventually you might be interested in joining these activities. As Remco mentioned, I think the availability of new technologies opens new windows for us. And, World Federation of Neurorehabilitation is aimed to increase knowledge, increase research, increase education, and augment the quality of services in neurorehabilitation around the world. And we are faced in a situation that hundreds of millions of people in the world do not yet have access, and will in near future not have access to classic means of rehabilitation, by rehabilitation hospital, inpatient, outpatient department, things like that. So we have to rely more and more on outreaching by using digital technologies. And if there was anything good from the bad COVID-19 pandemic, then it was, at the end of the day, that our ease to deal with these technologies has increased very much. So we look forward to that. Remco is introducing our first speaker, Dr. Tom Butcher.
Yeah, because we are very pleased not to be just Volker and me, but we have some high potential speakers amongst ourselves this afternoon. And first of all is Tom Butcher. Tom is assistant professor at the Department of Sport, Exercise and Rehabilitation in Newcastle at the Northumbria University. He did a lot of work in his career on several illnesses, including orthopedics, neurorehabilitation. He worked as a physiotherapist in London, so he has some boots on the ground. But now he's leading very interesting programs and projects, including how the use of virtual reality technology and neurorehabilitation could work out for, especially for post-stroke upper limb rehabilitation. So I'm very pleased and honored that he's joining us today. So Tom, the floor is yours.
Just a brief administrative comment before. For the audience, please use the question and answer section and the chat section for comments and questions. We will have a short discussion after each talk, and we'll certainly have time for a general discussion at the end. Thank you.
All right. Thank you. Thanks, Remco, for the introduction. I'm just trying to share my slides, so hopefully this is going to pop up for everybody now. Has that worked? Marvelous, great. Well, yes, thank you for the introduction, and thanks for the kind of welcome to come and talk to you today. So, as Remco said, I'm Tom Butcher. I'm an assistant professor in physiotherapy at Northumbria University in Newcastle, and my plan for my kind of half hour with you today is to talk you through the development of the NeuroPhoenix platform for upper limb rehabilitation post-stroke. So I'll talk you briefly through the phases of development of the device and also the different phases of the studies that we've done so far. So that includes the phase 0, usability, safety, and user experience trial, our phase 1 feasibility intervention study, and our phase 2 feasibility randomized control trial. And I'll also talk a little bit towards the end of the kind of future prospects of what we're hoping to do with our phase 3 trial, which would be a full randomized control trial. So I'll start by just doing a little bit of an introduction to what the platform actually is. And you can see through the pictures there how it's developed over the years from what looked like and was quite a clunky device back in 2017 to what is quite a slick device now. So it encompasses the Neuro ball, which controls, well, contains motion sensors, and you can use it either in a base, so you can use it for movements like wrist flexion and extension and pronation and supination. And it also activates with squeeze and release. So it's like a specialist joystick that allows stroke survivors to engage in gamified upper limb rehabilitation. You can also take it out of the base and calibrate it to movements in any kind of plane of direction to use it for more full upper limb exercise as well. So that's what I mean when I'm talking about the NeuroPhoenix platform and the Neuro ball. The platform is that the ball connects to a specifically developed rehabilitation app, which turns those movements into gamified activities. So you can play all sorts of video games essentially through hand and arm movements. And one of the interesting things with the Neuro ball is that it calibrates. So each time you turn the device on, it asks you to produce as much movement as you have into each of the different directions and squeeze and release. So even if you have only very, very small amounts of movement, the games will then be sensitive to that much movement. Whereas if you have quite a lot of movement, then the games will respond and will push you to produce as much movement as you can. So it's a specifically designed and co-developed device. It's been developed by software engineers, by clinical specialists like myself, but also stroke survivors throughout the entire story. And that's essentially the story that I'm going to be telling you as I go through the talk today. But for some context, Remco mentioned the fact that, I did used to work as a physiotherapist. So I've included a little picture on the screen here of a slightly more fresh-faced version of me 10 years ago when I was a clinical physiotherapist, a neurophysiotherapist working at Chelsea and Westminster Hospital in London. And I was finding myself in a position which I think a lot of you on the call that are therapists will be able to relate to, that I would finish my 45-minute rehab session with a stroke survivor, would get them back to their bedside, and they would turn to me and say, great, what do I do with the other 23 hours of my day? And we know that on average, stroke survivors spend between kind of 21 and 23 hours of their day in sedentary behavior, not engaging in rehab. And that's such valuable time that we could be making use of. So as a relatively junior physiotherapist, I used the means that I had to me at that time. So I combined my other passion, which is music, with rehab, and myself and one of the music therapists did a little project and study where we would get everyone in the day room on the stroke unit, and we bought a load of instruments that you could play with your hands, and we were trying to get people using their hands to engage in music-based rehab. And that was my first little foray into the world of kind of research, essentially. And then I started to develop a bit of an interest in technology-assisted rehab. And back in those days, I know technology's moved on a lot since then. The only option we really had available then was the classic Nintendo Wii. So we bought a Nintendo Wii and a balance board, and every Friday afternoon we would do kind of the Nintendo Wii Olympics. And it gave me a bit of an insight into how much enjoyment people can get through gamifying their rehabilitation. But ultimately, that still had to be supervised. I couldn't kind of set patients up easily on their own to use an off-the-shelf platform like a Nintendo Wii. So this led to a career change for me, and I ended up taking up a research assistant position at Brunel University in London and working on the RHOMBUS trials using the Neurorehab platform with Professor Cherry Kilbride. So as I joined Brunel, we were working alongside two guys who had just finished their master's degrees in biomedical engineering, called Guillaume and Dimitris, who are the CEO and CTO of Neurorehab, the company, which they founded as kind of the outcome of their master's project. They both had family members who had had strokes and were frustrated at the fact that they weren't being empowered to do their own rehab and self-directed rehab. So they developed this very basic version of the Neuro ball with one of those snap bands to try and attach it around your wrist, with this clunky system to try and secure the ball to the base, because it had to be stable and neutral for it to calibrate to its neutral position. And they brought that to us, and we completed our phase 0, we'll call it, usability, safety, and user experience study. And this really was quite basic. So it involved a weekend where we brought 18 stroke survivors through connections that we already had at Brunel University into our teaching building. And we just let them all have a go at using the device. So we were collecting basic metrics, completing questionnaires on how easy was it to put their device on and use the device and navigate the platform and play the games, and which games did they enjoy, what kinds of games would they like to be developed. So this was just a single day, lots of data collection, but it gave us lots of really valuable experience. And in particular, it gave Neurorehab, Guillaume and Dimitris, some really useful feedback from stroke service users on what they needed to do to further develop and improve this device that they'd developed. So that then led on to our phase 1 feasibility intervention study, so an acceptability and feasibility study. So we were successful in getting a £400,000 grant from Innovate UK, and some of that money went to Neurorehab, which really helped to spearhead their development. It allowed them to bring in and invest in staff who could come in and do things like the games design and the software design. And then a chunk of that money came to us at Brunel University so that we could run the first clinical trial of trying to get people using this device for upper limb rehabilitation. So this phase 1 trial, we're looking at the Neurorehab platform for home-based rehabilitation of the arm and hand after stroke. And the big thing here was we were wanting to look at trying to get a device into the hands of stroke survivors that they could use for their own rehab, that didn't need the supervision of a member of staff. And we had 3 fundamental questions, or 3 research aims for that project, which was, is it safe? We didn't know that yet necessarily. Was it going to cause people pain? Was it going to cause people injury? Is it possible? So can you realistically train someone in how to use a device like this and then just leave it with them for 7 weeks and expect them to use it? And the big question is, do people actually like it? And do they want to use it? And then how much do they use it? So in research terms, we call that safety, feasibility, and acceptability study. So we recruited 30 community dwelling stroke survivors. They were all chronic stroke, so all kind of well beyond the 6 months post-stroke, which was largely because it meant we could bypass NHS ethics, which obviously takes quite a long time to get through. And it meant that we had people who were kind of well settled at home and they weren't undergoing any other active treatment. So these were all people who were well out of the back end of the stroke services and the rehab services that they'll be provided with post-stroke. And we went out and we trained them in how to use the platform. I was the man on the ground for this as the research assistant, going out to people's homes and teaching them how to use the platform and use the device. And we left them with the device for 7 weeks to use it on their own. And we recruited really quite a wide range of individuals, which was really what we wanted to do. At this point, a lot of technology trials had recruited, on average, younger participants, but also people who were fairly mild in terms of their level of upper limb impairment. And I would argue that if you've only got mild upper limb impairment, there's quite a lot that you can do to get somebody actively using their upper limb. The group which is most difficult are the ones with very little hand and arm movement, because there are only so many ways that you can come up with inventive, exciting exercises to get somebody to try and do the high number of repetitions required to use their upper limb every day. So you can see here that in terms of the age range, we have people from 36 right the way through to 85 years of age, with a median age of 60, so slightly younger than average for stroke survivors, but similar to other studies. In terms of years post-stroke, like I said, they were all very much into that chronic phase post-stroke, with a median time of almost 5 years post-stroke. And then the other key thing that I've alluded to already is the fact that we had a really inclusive kind of characteristic group in our participants, from people who were scoring 0 on the Action Research Arm test right the way up to 57, indicating that we had participants with a very wide range of impairments included in the study, from very severe impairment through to very, very mild impairment. So what was the feasibility of delivering the intervention? So me going out to train people in how to use the device, on average, it took 98 minutes for me to train somebody in how to use it. And that was mostly in one single session. So one visit to their house, about an hour and a half of my time, teaching them how to put the device on, how to navigate the menus, how to play the games, how to use it, how to charge it, all of those technical details. And then over the course of the 7 weeks, they needed 123 minutes of total time. That includes the training. So only about an extra 25 minutes over the 7 weeks of input from me for troubleshooting problems that they had. And then they needed occasionally a bit of technical input. The device was still at a very early stage, so we had some glitches, some occasions where the app would crash, and I might need to go out and help somebody reset it or re-download the app, for example. So over 7 weeks, the maximum amount of time, or sorry, the average amount of time required was just over 2 hours of input from me as a member of staff. And what did that mean in terms of fidelity of how much people used the platform? So the cohort median across the full 30 participants used it for an average of 17.5 hours over 7 weeks. So about 150 minutes of upper limb exercise per week using the NeuroPhoenix platform, which equated to an average of 15,000 repetitions of movement, because the Neuroball will track all of this data and will give you massive data sets if you want it. But what's also interesting is when you look at the top 15 users, and I think this is an acknowledgement that not everybody is going to be as accepting and as open to using rehab technologies. And we need to know that some people it'll work brilliantly with, and some it won't quite so much. So when we look at the top 15 users, actually they were using it for almost 240 minutes every single week for 7 weeks, which actually would cover, so the 45 minutes, 5 days a week of the old stroke guidelines, they would have been meeting those guidelines just through using the device alone. Though, like I said, admittedly, that is looking at the sample of just the 15 most prolific users of the platform. Some people were using it massive amounts, using it up to kind of 340 minutes per week. The safety, we saw no changes in general fatigue or pain or spasticity in the upper limb. And we saw improvements in upper limb pain from baseline to 12 weeks. So our outcome measures were collected at baseline, at 7 weeks after they'd immediately finished using the device. And then we also had this 5-week follow-up to see whether or not any changes were carried over after we took the device away. So upper limb pain was one where we saw improvements from baseline to post-intervention to the 12-week follow-up. We saw that the odds of reporting shoulder pain was reduced at 8 weeks compared to the odds of reporting at baseline. And the only adverse events were mild and short-term things like muscle soreness, which you'd expect from any kind of upper limb exercise. The preliminary efficacy, now this wasn't powered for change, this was a feasibility study ultimately, and we saw no change in our pilot primary outcome measure, which was the action research arm test, but we did see improvements in wrist extension by 10 degrees and shoulder external rotation by 7 degrees. And these improvements were maintained at the 12-week follow-up as well. And then in terms of our more kind of qualitative data from questionnaires, we also found that participants were reporting things like improvements on measures of participation. So they were using their hands more for things like getting dressed and doing the washing up and the cleaning, which is a really positive thing to see as well, because it's not just about the pure numbers of, you've had an improvement in the ARIT. It's also about actually, does this, help people to use the hand more day to day. Acceptability we measured in 2 ways. So one, through questionnaires, and we found that people enjoyed playing the games. Most people were a bit reticent about us taking it away. They wanted to carry on using the platform. And most also thought it did have a positive effect on their arm and their hand. We used the Quest to look at satisfaction levels, which were high. So 36 out of 40, with 40 being the maximum score on the Quest. So people were very satisfied with it. And we had 3 participants withdraw from the study, with a couple of them struggling a bit with using the device fully independently. But this was also a mixed methods study. So we also did qualitative analysis of participant experiences. So we recruited 18 of the 30 participants, and we did that purposefully to make sure that we had a mix of age groups and also people who didn't use the device very much and people who used it a lot. And we found 5 themes through our qualitative analysis. One was the reasons why people had enrolled in the trial. And the big thing here was that people felt like they had fallen through the gaps and they were no longer receiving any input. And ultimately, it was hope and hope for recovery, which had caused them to take part in the trial. The perceptions of pre-trial preparation and support, everyone felt very supported. They felt that the support that we were provided from both Neurophoenix and us as the research team, and that they were well informed about the study. And then we get more into the acceptability and usability of the device. And we had a theme around device usability and comfort, where we did find some things like participants reporting that they might need to do 5 minutes of stretching of their hand before they are able to get the hand into the device, but the overall comfort levels and usability was high. The factors motivating persistence is where we found some interesting elements of the enjoyment of playing games. There was a leaderboard on the app, so people were able to see how much they were using and where they sat on leaderboards. It admittedly wasn't a live leaderboard, but even just having a very basic leaderboard there gave them an element of motivation. And we also explored some interesting concepts around whether people would be interested in things like gaming with other people, so they could go online and play a game against another person, with the majority saying yes, but the occasional person also saying that they wouldn't be so keen on that online gamification element. And then perceived effectiveness of the intervention. Again, we largely found that people thought that the device had a positive effect on their hand and their arm, with people reporting things like the hand feeling looser and like the tone had decreased after they'd been using the device for, say, 20 or 30 minutes. So overall, we'd say, yes, it's possible. Do they like it? Yes. Is it safe? Yes. And the QR codes there on the screen, which I'll put up again at the end, if you want to find the papers for the quantitative and the qualitative results from that first study. So that led us on to the phase 2 trial, which is a feasibility randomized control trial. So this time we got some funding, £80,000 of funding from the Stroke Association, very kindly from them. And we worked with our clinical partners in the NHS, who were Central and Northwest London NHS Foundation Trust, who run the Community Stroke Rehabilitation in West London, and Hillingdon Hospital, who were our local acute stroke unit where we recruited participants from. So we recruited 24 stroke survivors, all in the acute and subacute phases post-stroke from the acute stroke unit, and they were allocated on 2-to-1 ratio to the intervention group and the control group. So we had twice as many, 16 participants in the intervention group and 8 in the control group. Again, we can see that The characteristics of who we recruited ranged quite a lot, from 35 right the way up to 89 years of age. We can see that certainly compared to the first study, with an average time post-stroke of 5 years, we're now looking at 17 and 16 days between the two groups as our median time post-stroke, or sorry, our mean time post-stroke. And again, looking at the Fugel-Myers scores at baseline, we can see that we have a really broad range again of severe impairment through to mild impairment. So again, it's been a broadly very inclusive study. Interestingly, it took 98 minutes again to train people how to use the platform. So it took exactly the same average amount of time to train someone who is acutely post-stroke to use the platform as someone who was chronic post-stroke. Although one interesting thing with this was that whereas in the chronic phase, it was usually one single training session, in acute stroke, it tended to be 2 or 3 training sessions, indicating that maybe the element of fatigue that we see immediately post-stroke means that people can't manage such long training sessions. That needs to be broken down into slightly more shorter repeated chunks. The fidelity, we did see people not using the device as much. So whereas we had an average of 149 minutes per week of use in chronic stroke, in acute stroke, people averaged 94 minutes per week of device use. Though a kind of key thing I'd say there is that in the chronic survivors, they weren't receiving any other intervention. Whereas in this acute trial, participants were still in hospital, or if they'd been discharged home, the device followed them home, and it was used at home as well. And they were receiving their standard care. So if they were in hospital, they'd have been having their physio and OT and speech sessions every day. If they were at home, the early supported discharge stroke team would have been coming out to see them. So this is 94 minutes in addition to the standard care that they'd have already been receiving. In safety terms, just like the first trial, we saw no changes in general fatigue or spasticity, although this time we did see that the odds of reporting shoulder pain had increased, but this was in both groups, and it aligns with the current literature that says that a painful shoulder is common post-stroke, and that shoulder pain tends to develop and worsen in those first 6 months post-stroke. So although we did see an increase in shoulder pain, we think that that wasn't to do with the intervention because it happened in both groups, and it's an expected part really for most stroke survivors, unfortunately, in that first 6 months. The related adverse events were mostly mild and short term, with again things like muscle soreness being the main complaint. And there were no significant between group differences in the total number of adverse events. So again, we'd say that using the device in the acute phase post-stroke is safe to do. The acceptability of the platform, initial interview analysis has shown that there were some frustrations with technical problems. So whereas when using the device at home, it was relatively easy to connect people's devices to their home Wi-Fi because the device does need internet connection. Anybody who's tried to use any kind of device on hospital Wi-Fi will probably know the frustrations of trying to use it. And that certainly came across with some of the participants using it in the hospital setting with things like Wi-Fi dropping out. Participants really like the haptic feedback. So the device will vibrate, giving sensory stimulation and haptic feedback. And we had some really good positive feedback around that. And again, a bit like the first study, people thought it generally had a positive effect on their hand and their arm. Quest scores, again, were an average of 36 out of 40, indicating very high levels of satisfaction with the technology. And we did have 3 participants not complete the full 7-week intervention. 2 of those were due to adverse events. One was a participant developing a small pressure area on one of their fingers from having the hand in the device. And the other was an aggravation of historical carpal tunnel syndrome. It was something that the participant had suffered with for years, and using the device seems to worsen those symptoms a little bit. And then one participant withdrew from the intervention without giving specific reasons. And then feasibility of conducting a definitive trial, which is a big part of a feasibility randomized control trial. We hit our target recruitment. So we'd set a 10-month target to recruit our 24 participants, which we reached. So we're on target there. Our data completion at follow-up was 83%, which again, anything less than 20% is seen as a positive indication for going forwards to a full randomized control trial. And we had 2 participants withdraw from the control group, only one of which cited allocation to the control group as being a contributing reason for their withdrawal. So again, we've seen that now in acute and subacute stroke, we have a device that again is able to get people engaging with their upper limb rehab more in an enjoyable way. The qualitative analysis, so we did, again, semi-structured interviews with participants. I'm currently writing up the analysis for that, so that'll hopefully be out shortly, so you can see more about our qualitative data from the second RHOMBUS trial. But kind of shameless plug, the quantitative paper was published this morning, in fact, which was fantastic timing. So you can go on to BMJ Open, you can follow the QR code there, and you can now see all of the results that were published from the RHOMBUS II quantitative paper. Like I said, the qual paper will be following shortly. So that leads us to where next, because I think one frustration is that lots of these technologies go through these same 2 phases. They go through kind of preliminary acceptability, feasibility, pilot trials, and then they don't seem to go any further than that. And that is a massive barrier to implementation, because how are you ever going to get a system like the NHS to adopt the technology without being able to clearly demonstrate its efficacy? So what we're hoping is that we're now going to move forwards with a randomized control trial using the NeuroPhoenix platform. However, this is where we come across an interesting kind of prospect, because implementation is the biggest barrier. How do we actually get devices like that into use? And NeuroPhoenix as a company have actually left the direct to consumer market. So you can no longer buy a Neuroball or the NeuroPhoenix platform. What they've done is they've gone to the United States and they have become a healthcare technology company. So they've employed occupational therapists who in the States lead upper limb rehabilitation, and they are now Medicare approved in Florida and more states pending to deliver a 15-week telehealth program which utilizes the Neuroball. So the idea being that every week you have a video call with your occupational therapist. They have a platform where they can track how much you've been using the device, and you'll have a combined home program of device use alongside more traditional upper limb rehabilitation. And as I've said, in America, Medicare will now reimburse them to deliver that as a service, which I think is a very interesting prospect, because getting the NHS to try and shoehorn technology into it, I think is always going to bring big problems and barriers. So what I'm potentially going to try and go forward with this randomized control trial is actually trying to model what they're doing in the States by proposing that instead of trying to get the NHS to run this as a service, actually it's delivered as a telehealth program by a separate company, either NeuroPhoenix or the research team, to suggest that the implementation strategy is not for NHS clinicians to try and use this as part of their practice, but to actually get the NHS to pay a company to provide a telehealth solution, which uses either the Neuroball, but also other technologies as well. I am open and I'm interested, and I'm working with companies who combine functional electrical stimulation with virtual reality, mirror training in virtual reality, because I think no single device is ever going to provide the solution that we are looking for. We need to acknowledge that no single company should be aiming for 100% market share. It's far better that everybody works together and we accept that immersive virtual reality will work for some and non-immersive virtual reality will work better for others. And functional electrical stimulation will work well, but it's not for others. And it's about finding the best way to bring these technologies together and achieve implementation with them. So that's my kind of next step going forwards. So thank you everybody for listening. There are a load of QR codes for the RHOMBUS I quant and qual papers, the RHOMBUS II quantitative paper. And then if anybody wants to get in touch with me, feel free to reach out. There's my email address there, thomas.butcher@northumbria.ac.uk. And there's also a QR code for my LinkedIn account.
Okay. Well, thank you very much, Tom, for this wonderful presentation, and congratulations on the published paper today. That's extraordinary timing. It's well done, and thank you for sharing the insights.
Thanks, Remco.
There were some questions in the chat. Maybe we can go over that quickly. First, maybe for you, Volker, there's a question about the recording. Is the recording of today's...
Well, the recording will be available within the next week or so on WFNR website completely. You can have the entire webinar is recorded and you can go back to it anytime.
Okay, yeah.
It takes about a couple of days before it's implemented.
Then there was a question all the way from Ireland about the medical device regulations.
Yes.
And the requirements needed for your studies. Can you elaborate a little bit on that, Tom?
I must admit, I actually don't know a huge amount about the medical device requirements. That's one side where I've always left that up to the tech companies that I work with to manage that, and I do more of the clinical side. I'm not sure if anybody else on the webinar might have a better idea about the requirements.
Maybe our next speaker, who's also a bit of an entrepreneur, can say a few words on on that. But all right. There's a question on the slides. I think that's the same question of the recording. So then there was a question: how about the participants' prior experience in using gym equipment or other technologies in your cohort in terms of your study? Could you tell a little bit about that?
Yeah, absolutely. So we collected the kind of baseline data collection. We also used questionnaires to collect information on kind of current use of technology. And most participants had very little use of technology before in both of the two RHOMBUS trials. The younger participants generally were more tech savvy, though. An interesting finding was, I think I went into it probably with a degree of prejudice that I thought that the younger participants would get on really well with it, whereas the older participants potentially wouldn't engage so well. And it was almost the reverse, because the younger participants had grown up with technology and with gaming technologies. And in reality, the games that you can play on the Neuroball are all games that you can be adapted from open source code for things that are out of copyright. So it was things like Pac-Man and space shooters and Pong. And for the older participants, I think there was a degree of kind of reminiscence of games from their past, and they enjoyed playing them. Whereas the younger participants got bored really quickly, and they said things like, you know, if I could play Call of Duty or FIFA with it, then great, but I'm not going to sit here and play Pong for, you know, an hour a day for the next 7 weeks.
I can relate to that, having two boys in that heavy gaming age myself. So yeah. All right. Another question about the digital literacy. Might that have influenced the feasibility? Is a question of Nathan Skidmore.
Yes. So I guess we looked at the digital literacy in terms of how much people's prior experience with technology, and on a whole, I would say the digital literacy was low. So we certainly hadn't recruited a group of participants who were already very tech literate. Some people had never used a tablet computer before, and it was their very first time using it. But one other thing to say is that although we were talking about independent use, for many participants, family members also helped. So some of the interviews that we conducted were in dyad with family members who had been more involved in the process. And lots of people had people at home who were able to help, particularly with some of the early sessions. So very much an acknowledgement that technology literacy kind of can be a barrier, but also the app's been developed and in a way that is very intuitive. And that was one thing which came out of a lot of the qualitative feedback, was that actually the menu screens, the videos that pop up in the app, people found incredibly helpful, regardless of how tech savvy they were before they enrolled.
Another question: were there any other limiting factors while recruiting participants for the study?
I mean, so our recruitment rate for the second study, the acute trial, the recruitment rate was 12.5%. So certainly quite a lot of participants were were screened out, though that was largely just because they were screened as eligible. And then when they were approached, they kind of said that they weren't necessarily interested in taking part. When in the paper published today, there's a full consort diagram which outlines where people were screened out at certain points through the recruitment process. And so in terms of comparing to similar studies, that although it sounds like quite a poor recruitment rate for technology trials, 12.5% recruitment rate is actually relatively good. I'd say most technology trials recruit in the single digits for their recruitment percentage, from those screened as eligible to those actually recruited and enrolled onto the trial.
All right, thank you. There's a financial question, I guess. Do you know the Medicare CPT code for this device in order to be reimbursed for its use? Somebody from Florida or from the US, do you know that?
It's a very good question. I don't know off the top of my head.
No, you don't.
Like I said, it's only in Florida at the moment that they've got the Medicare approval. But if you go on the Neurophoenix website, then yeah, you can, or you reach out to me. I can easily put you in contact with the team at Neurophoenix if you're wanting the specific reimbursement code.
Okay.
I recently went out to the States for a conference and had to learn so much about reimbursement codes.
May I make a comment from a neurorehabilitationist point of view? I very much like this because that may help us to bridge the gap, especially in patients with moderate to severe impairments. So the question is, when you look at, you had people with Fugl-Meyer between 20 and 40 or so, something of that sort of magnitude. How much was the average gain in Fugl-Meyer scores with your training?
So we didn't see improvements on the Fugl-Meyer as a measure in either of them. Nothing which indicated any kind of degree of something that was worth reporting. So neither the ARAT in the second
in
trial,
the ARAT, how many points did you gain in the ARAT?
So in the second trial, in the acute trial, we saw an improvement of 8.6 in the intervention group. So it does pass the minimal clinically important difference of 6. So we would kind of go forwards with using the ARAT as our primary outcome measure in a definitive trial because it's showing signs. Although the control group also had an improvement of, I think, 5.5. So they were only just below the MKID. But we did see bigger improvements in the intervention group in the ARAT.
Okay. Well, a key issue for this always is intensity of treatment or frequency of interventions, which is probably the key issue for impairment-oriented rehabilitation, especially for upper extremity in general. The question is, you used, as far as I could see, about 30 minutes or so a day or an average, which is probably not enough.
Yes.
And what I would really recommend, with appropriate pauses in between, but I recommend to increase that by a factor of 3 or 4. I think that will probably help to increase the gain also on the ARAT as well as on the Fugl-Meyer. Eventually, we'll see.
Yeah, I think an interesting thing with that, Volker, is around the, these two trials are very much train them and leave them with it.
Yeah, sure.
And as a therapist, I was quite frustrated because people were saying, my hand would feel better after I've used it.
Problem.
And this movement now towards it being used as a combined treatment alongside, input from a physio or an OT to say, okay, well, maybe you use the device for half an hour and that warms your hand up. It helps with improving your flexibility a little bit. You get that little bit of movement that we saw reported qualitatively, but then you say, now we're going to do our standard repetitive task practice, our functional based training. And I think realistically, it's the combination of the two things which are going to achieve that higher level of intensity.
Okay, but final short question. What about people with severe upper extremity problems in addition? Because it takes, you need to wear a little there's a weight to lift it up, right?
Yes, so you can use it in the base. So for people with more severe impairment, they would have it resting on the table in front of them, and it sits in the base and supports it. And we had some participants, the ones who were scoring zero on the ARATs, they would do it assisted. So they would use their unaffected hand to help guide the movement to begin with. And then as they started to feel like they had a bit of movement, they would then start trying to use it unassisted as well.
Yeah. Okay. Right. There are no more questions. One making a comment, how can you say improved if there are no substantial changes in outcome measures, such as the Vogelmeier and the ARAD? Well, there are some, but it's yeah.
Yeah,
everyone who's working in this field knows that the margin in some sense is limited. It's not a magic thing, right? Yeah. Good. Okay, Remco, we got.
Yeah, then let's move on to the second speaker, who's from the Netherlands. It's Melvyn Roerdink. Melvyn is a professor at the Amsterdam, the Free University of Amsterdam, associated to the Faculty of Behavioural and Movement Sciences, focusing on prevention and rehabilitation. But Melvyn is also an entrepreneur, or has an entrepreneurial spirit, and always liked technology. He did some work with the world famous C-Mill. He developed programs for the Microsoft HoloLens. He worked with Kinect, the Kinect sensors, and he is the Chief Innovation Officer of a very interesting company called Strolll, doing augmented reality therapy. That's a one that everyone in neurorehabilitation should have on their watch list. So I'm very pleased that he's here, because he was severely impacted by pneumonia lately, but he's here, he's alive and kicking. So, ladies and gentlemen, with no further ado, here is Melvyn Roerdink.
Thank you, Remco, for the excellent introduction. It makes me shy, to be honest, but I'm happy to be here. Indeed, I had a pneumonia, so every now and then I need to cough or catch my breath again. So then I will mute myself. Apologies for that beforehand. Let's see, share my screen. And then maybe this one. I think we're all ready, right? All set? I think so. All right, so let's get ahead. So Remco asked me to give an overview of our work on augmented reality neurorehabilitation, and our intention is really to bridge the gap between supervised in-clinic care and make the move towards digitally supported independent care at home. This is important because of the shortage of staff. Especially in aging society, there's going to be a huge care infarct where there's not enough staff to treat the increasing numbers of patients. And augmented reality technology may have the ability to make that transition happen. Yes, so that's the content of my talk. And indeed, I'm wearing double hats. So I work at the university, actually 2 universities. I'm making a transition from Amsterdam to Maastricht in the Netherlands. And I also work for Strolll as the Chief Scientific Officer and being part of the leadership team. As a scientist, so wearing the scientist hat now, I was always been interested in technology in motion. That means cool new technology to measure movement, improve movement, assist movement. And one of those technologies that I really had my eyes on was augmented reality technology. So when the HoloLens was introduced, I was thinking, yes, this is probably the next step that will have a big impact on the field of neurorehabilitation and physical therapy. So there are obviously many ideas that can utilize this technology to promote or measure or assist movement in context, so in the clinical setting or even at home. And the question then is, okay, if you have those ideas, what are then the next steps? And I think collaborating with a company is, or working both at the company and the university can be really beneficial in that sense. Why am I so passionate about it? Well, first and foremost, scientists have many ideas, and most of those ideas also have a relevance for our societal relevance, and in the context of neurorehabilitation, often also clinical relevance. But there is a huge problem, and that is that most of those ideas never leave the building of the academia. And and as a consequence also never reach society. And to me, that is a waste of taxpayer money. It is also not a good incentive towards some governments that really have severe budget cuts planned on academia. And I think as a scientific community, maybe we should also be more reflective of that sense and try to improve on that aspect. And to me, it's always been a big driver to ensure that the ideas we had and the solutions we come up with have tangible real-world impact and are at least tested for broader potential than just scientific success. I found that important. So as a side note, maybe on impact. So in academia, we often celebrate high impact, like a publication, or a grant, and then we are happy and we are getting rewarded, and there's some champagne and bubbles. But these are bubbles in our academic bubble, and we far too often fail to generate tangible impact for our society or the patients we try to serve with our research. And that's also been introduced by Tom in the previous talk. And my mission really is to generate tangible real-world impact with my academic work. So outside of our academic bubble and into the real world, into the hands and heads of our patients. Yeah, I realized that this was something I was passionate about. So Remco already introduced the CMIL. There was the outcome of my PhD project that's supposed to the topic's supposed to be tapping to the beat of metronomes, but then, yeah, I found it very difficult to explain to my grandma the relevance of that. So I quickly pivoted towards cued walking, auditory cued walking in stroke to modify the gait pattern, and then to all sorts of accidents and happy coincidences. This resulted in the world's first augmented reality treadmill that is now on the market through Motec and Hokoma and DIH, and probably in some of your facilities as well. What I really liked about this are comments from clinicians and patients that they really, yeah, that this type of rehabilitation really was beneficial for them, and that to me is more rewarding than another scientific paper. So ideas are easy. As scientists, we have many ideas. The execution of those ideas to make things happen, that is really what counts. And I've learned through the development of the CMIL that public-private partnership teams are really beneficial in making that transition from an idea to a real-world impact much faster. So that's why I'm very happy to work both at the university with many collaborators as well as at Strolll, where we will try to revolutionize the field of neurorehabilitation, especially trying to bridging the gap between from the clinic to at-home rehabilitation. Just to know we are all on the same page here, I will be talking about augmented reality solutions, which differ from virtual reality solutions that most of you may be familiar with. And to make that distinction crystal clear, I have a short video to show you what the difference is between virtual reality and augmented reality.
Actual reality, sick.
Yeah, it's really sick indeed, and especially if I tell you that we go a step beyond actual reality with our augmented reality glasses. So augmented reality is different from virtual reality in the sense that you can see the real world surrounding you as is, and not fully immersed in a virtual environment. Why we think it is important for the type of therapy we would like to deliver is, imagine if the battery dies or the computer crashes, your patients find themselves in a pitch black environment. And that's very, that can be very unsafe in an unsupervised home setting. So augmented reality glasses where you can still see the real world as is in an unblocked manner, I think makes a lot of sense to use in rehabilitation if you are out and about and not trying to rehabilitate in a seated manner. So when I'm wearing these glasses in front of my office at the university, I can see the boring corridor. But when I'm turning the device on, there's always this monkey present that's eating a pizza, and I can see that monkey from all angles. I can walk towards it, and I can also see my own limbs relative to that monkey. And that triggered a whole set of ideas how we can make useful applications for neurorehabilitation in the context of cueing and Parkinson's. Needless to say, perhaps, is that because you can see your real world, we are not, with augmented reality, challenged by typical virtual reality issues like depth perception, visual motor mismatch, motion sickness, and what have you, which I think is, again, a strong pro for using augmented reality in rehabilitation. Okay, how does that work then? Augmented reality glasses have a set of sensors, a computer. It's basically a computer on your head, and those sensors scan the environment. And because they know their environment, they also know your position in that environment. So it gives you the orientation and position of the glasses in the environment. And because we know the environment as well as your position and location in the environment, we can present augmented reality context that feels as if it is stationary in the real world. So if I wiggle my head quite quickly, that monkey remains on the same location in my corridor. And the 3D mapping of the environment, I think that's a unique feature that opens up all sorts of options. So we can present augmented reality cues for Parkinson's rehabilitation in the home environment, not floating in the air, but connected to the ground, for example, that really afford stepping onto it or over it, similar to the example I gave with the monkey. And we were lucky to get funded by the Michael J. Fox Foundation to really show the initial merit of doing this in home environments in people with Parkinson's disease. So here's the basic idea. There's a 3D mapping of the environment, and we need to interact with the computer. And we did decide to do this with voice commands. So we don't have a keyboard and a mouse. We need to interact with the computer in a different way. And voice commands is something that could work. So a practical situation, a Dutch setting, is a person with Parkinson's approaching a freeze-prone location, a certain narrowing of the walkable path, which may trigger freezing. And to alleviate, to prevent freezing, the patient can call cues on as a voice command, and then cues are presented in his environment, only seen by the person wearing that headset, that help him traverse this freeze-prone location.
Stepping stones on. Stepping stones off.
So that's the idea. We did a study in 24 patients with severe freezing in their home situation to examine the potential for improving walking speed and step length and alleviating freezing of gait at home with the application we built in this Michael J. Fox project called HoloCue. And HoloCue, these are two videos of the same person wearing the headset without and with HoloCue cues present.
Man, ik ben er nooit zo snel.
That comment was Dutch for I've never been around that corner so quickly. And you see on the left situation there's a lot of freezing around the saloon table, whereas in the right situation that wasn't the case. So with the cues, the augmented reality cues, walking speed is much faster. There's longer steps and there's no freezing. Whereas without the cues, there's a lot of freezing. So we basically demonstrated that what we already know, that visual cues can be helpful for preventing freezing and assisting gait, was also effective in wearable augmented reality technology. Then by coincidence, I got called by the CEO of Magic Lines, and he said, "Hey, competitors, shall we join forces and make impact together? There's a grand deadline in 2 weeks' time." Magic Lines was a company, a very early startup based in the UK that was founded by Tom Finn, whose father had Parkinson's, and his therapist said, "Yes, try these colored lines in the kitchen and see how that affects his walking." And that worked remarkably well for that person. But then, you need to present those lines in the entire world, which is not feasible. So Tom was thinking, okay, how can I make the a wearable situation of those lines, and then augmented reality came up. So similar ideas as HoloQ, but approached from a different angle. My response, wearing my scientific hat, was, okay, sweet, let's start the conversation. I'll be back in 3 weeks' time with you when I have the NDA ready from my university for you to sign, and we can start the conversation. So this is signaling a big problem in public-private partnerships. Academia and maybe also large clinical facilities are really like oil tankers. They move in a certain direction and are difficult to change speed and to have different versatility compared to, let's say, a startup that is more like a speedboat. And that time scale separation is really a thing if you collaborate between those sectors. Just as an example, if you apply for a grant together, then the CEO of a startup may think, okay, now we can start the study. 3 months later, the study is done. 4 months later, we have a publication. And actual fact is, okay, if you are successful with the grant, which is not a given, then it takes probably 3 to 6 months before you can start the study because of ethics. Then we have to conduct the study. If the study is done, then it takes another 3 to 4 months to analyze the data and write it up. And then it can take another year or so to get it published. So there's a huge timescale difference between perceptions of the private sector and the reality of the public sector. So it's really important to invest proper time and professionalize your relation with in working together in a public-private partnership collaboration. And I was lucky to have a good professional support from the technology transfer officers who also helped me with CMIL at the time. And we did make it happen to agree on basic collaboration agreement and write that grant in 2 weeks' time, which is quite remarkable. And we were also successful, which is even more remarkable, which started off a great collaboration between our university and Magic Lines, later Strolll. With that Eurostars grant, we first studied whether we could modify Parkinson's gait with AR cues. We did this in the lab, and we compared real-world cues projected onto the server, similar to what we can do with the CMIL. And by changing the distance between those cues, we could also modify the gait pattern. Not surprisingly, the question is then, can we do the same with augmented reality glasses? So that's what you see here. Now the cues are not visible in the real world, but only for those wearing the headset in the form of dinosaur footprints. And if we change the distance between those dinosaur footprints, we can also change the step length of our Parkinson's patients. So yes, augmented reality cues have a strong gait modifying effects in similar way as we can do with real world cues. We also focus on other aspects of gait, such as speed and step length, crossing step length and step height, and also those could be modified in similar ways with real world context and augmented reality context. We focused in that grant also on augmented reality data science, so the data from the headsets provide very useful information for example, parameterizing the clinical tests like a time tap and go test, the 5 times sit stand test, 10 meter walk test. And we can not only match the test completion time scores, but also provide additional information about how long it takes you to turn, how long it takes you to stand up, to sit down, etc. Similar for walking, we can, based on the characteristic vertical oscillations that we see, with stepping, we can give indicators of cadence and step length and what have you. And this will be published anytime soon with Peter van Doren, I think in the coming 2 weeks. Happy to share a preprint, drop me a note if you are interested. Yes, something else. Those headsets measure the environment, and those environment may provide features that may be relevant for triggering freezing of gait in people with Parkinson's, such as the aperture in the walkable space. So what that means is that probably we can use that information to identify whether a person will freeze prior to when indicators of movement suggest that a person will freeze. So we built a machine learning model that uses not only movement data, but also environment data to predict freezing of gait in a real-time manner, and found that a combination of the two classes of information outperformed the scores of only when only using movement data. So here you see a person walking in a mapped environment with the headset and color-coded for the type of motor state the person is in. So if a person is walking, standing, sitting, but also freezing, those red parts. And the nice thing about such a model, which is patented, is that it may allow for automatic cue activation. So the person doesn't need to activate it him or herself, but it can be automatically activated based on features of the environment as well as in the movement of the patient. And this is something we will be, this idea is something we will make a reality in the Navigate project, which is an AI-supported assistive navigational AR cueing solution for people with Parkinson's disease that really understand users in their environment. And this is a European project, quite big for bridging the gap between a demonstrator product, an MVP, towards a regulated commercial product, in this case, a medical device. Yeah, public-private partnership. Here is the CEO of Strolll that gives a comment about the importance of collaborating with academia and vice versa. So I can take, yeah, I would like to share with you so I can take some breathing back. Sorry.
Hey everyone, my name is Jorgen Ellis and I'm the CEO and co-founder of Strolll. We're based in the UK, startup company that develops software for augmented reality glasses for physiotherapy and rehabilitation. Melvyn's asked me to give some quick input on my take on the AR field and also about sort of private and academia relationships or partnerships. So very quickly, I'm bullish on the future of augmented reality. I think previously we've seen VR be more widely adopted and AR be specific niche cases. But I think we're seeing that flip now, where virtual reality will be used for niche cases where, you know, fully immersive environments are most beneficial, like cognitive behavioral therapy or education, perhaps in a classroom environment. And augmented reality is going to be more widely used and adopted because of the seamless integration that can happen into our work and our lives with see-through lenses and the digital enhancement of the actual real world, which is where the real benefit of where I see extended reality technology. I think it's similar to the mobile phone market. I think we're in terms of the development and the adoption. I think we're in the enterprise phase at the moment where we're seeing huge adoption in healthcare and a willingness to take on this technology. And as that happens, the cost will come down and consumers will eventually become part of that market as well. Now, in terms of partnerships, I think it's incredibly important that academia and private companies work together. And the key benefit that comes from that partnership is the acceleration of getting to market and getting these new technologies or these new methods and systems adopted by the people who need them most. We've been very successful in developing a great partnership with Vrije University, and that's where we brought our commercial expertise, where we could develop software much faster in a commercially acceptable way, that we could do the regulatory work, and that we could then pass that over to the university to do the scientific validation, which would then come back to us where we had the commercial expertise to actually get the technology and adopted. And now that's a cyclical relationship where the science is then informing future product development, and we're able to just do that together by operating in partnership at a much faster pace than what we otherwise would. So if anybody else is interested in partnerships or collaborations, how they work with us or with others, very happy to have a conversation. Please just look me up on LinkedIn or get my email. Thank you very much.
Yeah, so it also shows that for companies, it's really important to have close relationships with universities to drive product development and also product validation in scientific terms and clinical terms. So I just sketched some projects that are ongoing, but you can also question, okay, where are we now with our AR solutions for promoting, measuring, and assisting movement in context? And are we now ready for making the step from in-clinic use to independent training at home?
I'm Caroline.
And to show, I would like to show you first a video of how that's been done in practice using a case study from Strolll.
I'm Caroline.
I'm Brian Wager.
He's been diagnosed for about 5 years, but we believe he's had it for a lot longer, probably at least 10 years. We are part of a Parkinson's support group in Halifax, and Strolll were invited to give us a talk one day, and we were there, and we were absolutely gobsmacked by the fact that Brian walked without a stick. He was walking along the stage without a stick, and it just brought tears to my eyes, and people were just standing there with their mouth open. They couldn't believe it. It was just like he'd come back again. It was really emotional. Went further, we had appointments to see at the Nicole's physiotherapy in Leeds, and we found it absolutely amazing, haven't we? But they're very helpful because also they're monitoring how he's moving, and they're watching him, and they can see if there's been improvement, and they're advising him on how to help him with his walking and things. So it runs alongside it really well, actually.
Since you've had it, you've done 19 hours and 18 minutes of exercise with it.
That's brilliant.
Yeah, you've played 341 games, and you have walked 6.86 kilometres in total.
With Brian, if he's given exercises to do, he gets bored after a while, but with this, he just loves doing it every day. He can't wait to do the exercises, and he's sometimes 2 or 3 times he's in here doing the exercises, and he loves the games, and it's really benefited him because he's having to get up and down and move around and what have you. He's fitter, he's stronger, and you can see that he's moving about better. His walking's improved. Although he uses a stick, it has improved, and I just think it's amazing. It's like a miracle, really. He was falling at least 7 times a day, and that's been reduced to 2 to 3 times a day since he's been on Strolll. So that's a biggie, isn't it?
When you first started, Brian, your 5 times sit to stand was 16 seconds. And at the last measure it was 8.7 seconds, so almost half. Your time get up and go was 22 seconds, and it was 13.8 seconds at the last measure. And your 10 metre walk test was 18 seconds and 13 and a half. So improvements on all the outcome measures that we've used, so well done.
Things like this give you hope, it gives you hope that there are things out there that can help, and never to give up that hope, really. You never know what's around the corner, and I feel this is a big step forward in technology, as I've seen the difference with Brian, and not only just his mobility but his happiness. It gives him something to do every day. He's looking forward to, I've got to do my exercises, as he might have just sat there in front of the telly all day, but he's got something to do now, which is really encouraging. And I've seen a big difference. He loves the mole game, by the way. He loves hearing this squeak and this laugh when I'm out there and he's stepping on the moles. But the basketball, things you would never have done, would you? Yeah, so it's been very beneficial. I definitely recommend it to anybody. Well, we've been talking about it to all our family and friends, and showing them the video of the church when we were there doing the walk, and they were amazed. And it's a wonderful setup, and we're very, very happy with it, aren't we?
Yeah, makes me feel great.
Yeah, this obviously almost feels too good to be true, and it's a case study. And my task as Chief Scientific Officer is to ensure that this is properly backed up with scientific studies. And again, we focus now on Parkinson's disease, but we're making the transition also to neurorehabilitation for MS and for stroke patients. Last 10 minutes or so of this presentation, I will focus on the feasibility studies and the RCTs we have been conducting and are conducting at the moment for Parkinson's disease, which is a disease that really sucks, according to Michael J. Fox. That's represented with poor gait and balance. They fall a lot and it costs a lot. And it's a progressive disease for which exercise is regarded as medicine, so to slow down the progression of the Parkinson's disease symptoms. And that's much needed, as there's a strain on staff resources, the frustration patient, and enormous cost. So with Strolll, we developed Reality DTX, which is a remotely prescribed and digitally supported at-home AR gait and balance exercise program, which is, in terms of regulation, has FDA, CA, and UKCA approval as a medical device. And it's device agnostic. So we work with Magic Leap and HoloLens, but if let's say Meta comes with Orion as a commercial product, we can also make the shift to other glasses. The games are developed in co-developed by patients and therapists, so with users and end users, and this is really beneficial and makes the product much better than what can be delivered from the head of a scientist or a developer alone. What did we came up with? We came up with a set of exercises. The first is called basketball, and it's really not about throwing the basketball, but it's really about squatting or sit to stand movements that you first need to do before a basketball is earned to throw into the hoop. And it's a 6 weeks program, what we used in the first clinical feasibility study. And you can see already that the quality of movement of those squats improved dramatically from week 1 to week 6. And you can also see that we can set the gameplay in a progressive manner. So then more squats are required to earn those balls. Another game that some find funny is Mole Patrol. You really have to stamp on the moles, first scout them in your environment, then initiate gate, walk towards it and stamp on it. And also this can be made more progressive by changing the distance between locations where the mole appears to promote more walking and turning and scanning. So it's really about a game for addressing those aspects of gait in Parkinson's disease. Smash is another game. It's a boxing game. We focus here on an upright posture, so not the stoop posture, so hence the pillars are quite high. And alternate punches are required to also promote weight shifting and trunk rotation. And also here we can set it progressively from week 1 to week 6 by requiring more punches and a greater distance between pillars, for example. And finally, the game is called Hot Buttons, where the task is to reach out to a button with your correct hand, either the left or the right hand, as indicated by an indicator. And this is a game that focuses on standing balance, trunk rotation, quickness and scanning as well. And here we can have more buttons as a function of time, which makes the scanning more difficult and also a lower available response time. So the games can be progressively set. We had a high bar for ourselves. We said, okay, we would like to have 30 active minutes for 5 times a week for 6 weeks. And probably, well, I guess about 80% of you will not reach that activity minute target. Our patient did, so collectively they reported 15,000 active therapy minutes in which they walked around 200,000 meters in their living room. They were high adherent and there were no falls. Reality DTX was also well accepted with post-trial interviews and questionnaires, with scores I could only dream of when I was in high school, so that's promising. And we found improvements in time to go score, 5 times sit to stand score, 10-meter walk test score. But we also did more extensive assessment of walking ability in the lab, where we focused on precision stepping, speeding up, slowing down, and turning as markers for fall risk that came up in our previous studies. And the treatment was responsive for improving those aspects as well. Similar to Tom, we also value very much the qualitative research. So we also did qualitative research on what people's impression was of the therapy and if they accepted that as a therapy, as a complementary to physical therapy. And that was indeed the case. And they also raised valuable suggestions for improvement, which we took on at Strolll in the next iteration of the software updates. So take-home message, Reality DTX, based on this clinical feasibility trial, can be safely taken home in Parkinson's disease. When working with companies, and especially if you also work at a company, it's important to be fully transparent on conflict of interest, of course. And what we do as an additional step, which is also good in common practice, is to pre-register all the study protocols, so that the results that are generated by the public-private partnerships studies are credible. We're currently running a randomized control trial called CAPARA, which stands for Cueing Assisted Personalized Augmented Reality Exergaming. And here we implement the cues in the augmented reality exergames. And then here we started supervised in the clinic and then progressed independently at home, assisted with cues when deemed useful by the therapist. So at the clinic, the therapist plays around with various cues and selects the cue that seems to be most beneficial for improving the gait pattern, reducing freezing of gait, etc., of patients with Parkinson's disease. It was a pragmatic RCT, which means we as scientists leaned back and let it and have implement the program in the clinical pathway. So we recruited 17 centers in the Netherlands. We trained those centers in using the technology, and then we gave them a target for how many patients they should include, and then let things happen from there. So it's really a pragmatic trial, but it's also representative of a real-world setting and how to do, and hence closer to implementation information. Study progress, we recruited our target of 100 participants in different stages of Hoogendijk. 62 completed the trial, 16 are still in the intervention phase, and there are 22 dropouts. And on average, we record about 5,000 therapy minutes a week, which are nicely distributed over the days. Whereas in the weekends, of course, the therapists do not work, but the patient continue to train. There's a nice dashboard that complements the training. And on average, we see that people meet the target of 30 active minutes treatment per day. And this was, again, our bar. 30 active minutes, 5 sessions a week for 6 weeks. And collectively, we now have, for the 49 participants that we have the data from, recorded 38,000 minutes, active minutes of therapy at home, in which they walked 620 meters. So that is about 12 to 13 kilometers per patient, 51,000 squats, and a lot of reaches. So promising. Gait and balance issues are obviously not specific to Parkinson's, also relevant for stroke, but stroke have different challenges. So we have hemiparesis, we have hemi-neglect, and we are currently on a grant from Health Holland, working together with Strolll to customize those games to stroke patients, and also making the games targeting upper limb rehabilitation. So maybe Tom, maybe we should have a discussion and learn, so that we can learn from your insights in that regard. So that's going on, and that's it. I'm very happy for the opportunity to give a presentation, and thank you for your attention.
Okay, Melvyn, thank you very much indeed. It was a very impressive talk. I was thinking we are very much on the line in increasing avenues for fall prevention. Falls are the major source for brain injury in elderly people, with a tremendous economic impact. And I could foresee that using some of your AI technology may be useful for better tools for fall prevention. I come back to you in this respect because that is a major issue we are hitting at the moment. Okay, Remco, take over discussion.
There was a question by Stephen Wolf. Is there a persistence of effect once the AR is removed? So, or we, for instance, in Parkinson's, this also has this function. So, do you see an effect?
Yeah, that's a good question. So, if it is about the direct effect of cueing, then we see, of course, that in the presence of cues, gait improves sort of immediately. And the general belief is that if you then remove the cues, that effect disappears directly, because the cues act as an assistive device themselves. But yeah, when Strolll first published their case studies, I said, don't do this because you show an after effect, whereas we can't explain that based on the literature because cues are expected to work in the presence of cues and not in the absence of cues. But now we've seen so many patients that have experience walking on those cues for a while and then benefit directly after. We are now conducting a study to finding out why that is. Is that because of the neurotransmitters going wild in your head? Being very euphoric that all of a sudden you can stride again with big strides, or is it simply because you've been active for 30 minutes? We don't know, but this is something that's on our agenda to further explore in scientific research.
Okay. Another question from Stefania. She says, "Thank you for the presentation."
Can we meet at 5 o'clock, Sam?
Okay. Volker, you need to.
Okay, that's fine. Okay, because another meeting at 4:30.
Okay, Volker.
Okay, 5 is fine. Okay, 5. Back.
Okay, you are muted, Volker. So the question is, the physiotherapist in the videos always wears these headsets and AR glasses themselves as well.
Yeah.
Do they see different things? Do they see parameters? Can they manipulate, let's say, the exercise a little bit?
Yeah, that's a good question. Indeed, they can. So it's really about having the shared augmented reality environment. And the idea here is that as a therapist, you explain to your patient what he or she should supposed to do with, let's say, the squatting movement, meeting certain heights and threshold. He can also the therapist can also do it himself, and so that the patient can see, oh yeah, this is what I'm supposed to do, and then hand over control from being the therapist to being the patient without needing to switch headsets. So it's just a setting that you can take over the interaction control to the patient from the therapist to the patient, and that's been really helpful. Whereas initially, when we started, only the patient could see what he was seeing, and then all of a sudden there was an error in the software or so, and then but nobody else could see that error. So to us, for clinical use, having a spectator mode, that's how we call it, where therapist and patient can work together and see the same thing in the same augmented reality space, has really been a game changer in that sense.
I remember a question from the first speaker about medical device regulation.
Yep.
I'm sure that Strolll has faced those same questions.
Yeah.
You went through the European MDR regulations, and can you tell us a little bit about that?
Yeah, so it's currently listed as a Class 1 medical device in Europe. And we are making steps towards a Class 2A device, which also means that based on the data that we get back from the headset, we can make suggestions to the clinician. Probably you should now increase the difficulty level, whereas in the current situation we can't do that. And that the idea behind that, towards moving towards a Class 2A device, is that we can also do remote assessments. And that we can also free up the time of the therapist not having to prescribe all the weekly programs, but we can have an automatic program changing the settings of difficulty and progression. Another aspect that's very important nowadays, especially in the US, is cybersecurity. So I was a bit surprised that Tom with NeuroPhoenix connected to the local Wi-Fi of hospitals and users at home. We were not allowed to do that according to the cybersecurity specialists that audited us. So that means we provide the system also with a dedicated router with an own SIM card in it, which makes it also easier for the user because everything is just working without needing to connect and passwords, while at the same time meeting the cybersecurity settings that modern day digital therapeutic companies need to meet.
Okay, very well. Well, there's another a question about the co-design process for games, so you developed your own games for HoloMoves, but how does this work, and are there different options between therapists and patients? But can you tell us a little bit how the games appear on those platforms?
Yeah, so there currently are a limited set of games. We have 7 games at the moment. We are currently visiting all our games in terms of how we can improve those and make them more generic for other use cases. So fall risk is also on our radar, but also stroke, also MS. That's to make sure that with some additional settings or with some additional emphasis in the games, they are also very useful for meeting other rehabilitation goals. There's a pressing request from the field of having more seated games to also target more severely affected patients or patients early in their stroke rehabilitation, for example. So this is something that we are also working on, making settings specific between a stationary mode, sitting or standing, versus a moving around modus. And when we make changes, we have a panel of clinical users, which are therapists as well as patients who give us feedback on the iterations we implement, both first in writing and then also while experiencing it in AR. And there's obviously a group of stakeholders from a technology perspective, regulatory perspective, cybersecurity perspective, as well as commercial perspective, that need to have their say on whether a certain feature will be implemented or not in the commercial product. So it's not so simple anymore to come up with a game, because it's a listed medical device. There's a lot of paperwork involved and checks and balances.
Is there a limitation towards the difficulty? So at what difficulty does one stop using augmented reality?
Yeah, So our target population is not elite sportsmen. So if I can do it, then probably also the average patient can do it at the very highest level. I also use my children to test settings, and if they can meet it, and if they would like to play it for multiple days in a row, then probably it's also engaging for patients. Yeah, but there's not a really so safety is always an issue in those decisions. Yeah? You can make stuff very challenging that promote person to run or jump around. Probably that from the regulatory stakeholders say, well, is that really what we need as a rehabilitation goal, or is that putting patients at a too high of a fall risk at home? Yeah,
that's a question I would have as how do we scale up these virtual technologies?
Yeah.
Should we then ourselves build games, or should we just build the controller and let for instance the gaming industry build the games, and we only tweak the levels a little bit? How do you think about that?
So at Strolll, we are very open for the community to come up with game ideas. So we have a website for that as well, and clinical success managers that regularly engage with current customers on their game ideas, game tweaks. So it's really also with our existing customers, co-developing and finding ideas in the field that they think are essential for meeting their rehabilitation goals. So I think that is if you want to meet the requirements as a medical device, I think that's the best we can do, and not leave it to a random developer saying, okay, this is a nice game, upload it in your portal, and that's probably
that's not gonna work.
Not the way we should go.
No. All right. Okay.
Good. We carry on?
I guess so, Volker.
We should probably.
Yeah.
Okay. So our final speaker is addressing a somewhat different issue, using virtual reality, or let's say a digital world, to emulate a complete neurorehabilitation hospital. WFNR has set up this about a year ago. We started with that. The idea behind this basically is that we want to have teaching devices to make knowledge about procedures, techniques in neurorehabilitation available to a very, very large public around the world who otherwise do not have access. So let me introduce Michael Kaldasch. He is an MD. He worked with me for many years, but now for more than 10 years, he's the founder of a new company where we still stayed in contact. And so he helps us very much with his company Aimedis to bring forward this digital emulation business. Michael, if you are ready, we can go on with your talk.
Yeah, Professor, thank you very much for the introduction. So as said, my name is Michael. I'm a medical doctor, specialist in internal medicine. Have been working in neurology and neurorehabilitation for quite some time, and founded my company Aimedis in the beautiful Netherlands, by the way. Melvyn, Remco, right? So beautiful Netherlands near Venlo in 2017. I've been living for quite a long time in Amsterdam. I'm going to move back very shortly. Yeah, with my partner, who is also a medical doctor. We basically have like the same career. And yeah, during the clinical work, we always faced some issues getting in touch with patient information and stuff. So we founded Aimedis as a medical platform that was intended to combine data from patients, allergies, diagnosis, etc., to be shared with doctors, which, as you know, is not so creative as it turns out, because there are so many medical record systems out there. So we said, okay, what is the major pain point? Is always about data, right? And about the transport of information. And there's a big gap between the caregiver, the doctors, hospitals, and the patients on the other side. And we wanted to set up the Aimedis platform as a tool to fix that issue. On the one side with the data that we enable people to share, but on the other side with applications that help patients and therapists and doctors to treat the patients and to deliver care. And I don't want to be too broad with that. Speaking about neurorehabilitation, so what we developed was the first medical metaverse application, which is built on Unreal Engine. Thing is, I was a game developer before I started studying medicine. Back in the days, I was already a game developer, and I always wanted to make medical games and applications. And together with Aimedis, we saw the opportunity to do so. So we decided to say, okay, we wanted to say, how can we deliver this to the patient in a quality that is convincing? Most of metaverse applications and VR applications, we're going to speak about that and about the issues of VR, is that the quality is not so convincing, right? Because when you are in a virtual environment and it looks a little bit like a comic from 1990, you get motion sickness, you cannot relate to it because it's not, you cannot identify it with the real world. So we said, okay, we need to build this on an engine that delivers lifelike quality. And we went with the Unreal Engine, which is mostly used for high quality computer games, AAA games from big studios, but also indie game developers use it. It's highly scalable. It's developed on and on and on now, and it really offers high fidelity and great quality. And it's good on all kinds of platforms. Speaking of macOS, speaking of Windows, speaking of the Oculus, speaking of the Apple Vision Pro, for 2D, for VR, for AR. And that's why we went with that. And we started building Avalon as an environment that delivers lifelike environments for people around the globe. So we developed maps in a desert area. We developed maps in Australia. We developed maps in Europe to be shared by people who offer and accept services, one of which is the neurorehabilitation applications. And we said, okay, what would be an interesting approach for that? Where's the pain point? And one of the biggest pain points that we identified is delivering neurorehabilitative care to patients who need it. I can give a very good example. My father had a stroke, and he was in a peripheral hospital in a small city in Western Germany, and they didn't have any neurology specialists, and they don't have neurology rehabilitation specialists, which makes it difficult because, as you know, the earlier you begin the proper treatment, the earlier you begin rehabilitative care, the more effective it is, right? So we said, okay, how can we deliver this to the patient and what tools can we use? And we said, okay, we develop an environment where this application or these exercises can be done by patients in collaboration with physiotherapists anywhere, from anywhere and at any time. And we started digitalizing physiotherapy exercises with real therapists using an AI to digitalize them and to make them virtually available, right? So that you can see those exercises in 3D and can experience those exercises in 3D. And as Melvyn correctly said, sometimes it's difficult to have VR because some people, especially people that are neurologically impaired, they have an issue already with their senses. And when you deliver them a VR experience, that can be difficult. So we said, okay, we deliver this both in VR and AR. And we tried with a lot of devices. And I don't know, Melvyn, if you guys have already worked with the Apple Vision Pro, but we started working with the Apple Vision Pro, which has one problem. It's super expensive, but the quality is outstanding in terms of the AR applications. So what we have is avatars that are basically digital twins of physiotherapists performing neurorehabilitative exercises in a virtual reality environment, or alternatively as an augmented reality avatar in your own living room environment. In combination with, because there is multiplayer technology integrated, the therapists can join the patients inside this environment, and the people can communicate and speak with each other and do these exercises together. And we also integrated AI, OpenAI Model 4, and we're now looking to maybe integrate more modern technologies like DeepSeek. You know, this Chinese AI that just came out is insane. We've already started trying it out, but you can use this AI to not only deliver information, but it also can evaluate information, means you can analyze the movements a patient makes. So what we want to do with it is, and Professor Homberg can tell more about that too, we want to have patients doing the exercises that are being presented by the digital twins of physiotherapists inside their living room or inside the virtual environment. That is, for example, great for children. Unfortunately, children also can have neurological impairments and diseases and need neurorehabilitation. For them, the medical gaming idea and more those virtual reality environments might be more pleasing than just staying in their own living room. And then the AI catches different data points that we define. Melvyn, what I saw your presentation was really impressive. I would really like to speak to you because there are so many things that align with what we do or what we think about, because the data part is basically the most important of that, right? And building studies on top of that, all this impressive data is super important, because in the end, we need to have like an evidence, right, for what we do. We have quite some evidence with our metaverse applications in the field of cardiology and psychiatry. So we have some PubMed publications with some university hospitals in Lausanne and in Abu Dhabi and Cleveland Clinic in USA and so on, but not yet in the neurorehab. So we are yet to prove that this is going to work out, but we believe strongly in that. And the AI will help evaluate the quality of the movement. So does the patient lift the arm in the right way, or is it maybe only 90%, 80%, 70%? So you can catch up all these data endpoints and can evaluate not only the status quo, but you can also evaluate the progress. So in even the patient, which is a very good thing, because most of the patients, or even you as a specialist, you don't have an inner perception. How well are you performing an exercise? So maybe today you're doing it okay-ish, but you feel it was great. But in reality, the data would say it was just 50%. And another day you don't feel it being good, or you have the impression you are not progressing in what you do. But the data proves that you make a progress. So integration of artificial intelligence we see as a very important factor. And together with the technology, virtual reality, augmented reality, but also on 2D. So we are not asking people to have an Apple Vision Pro or a Meta Quest or any other device. They can just use this application on their smartphone or on their PC, on their Mac. They can even stream it onto a very old laptop or in a hospital PC, which normally doesn't have a good GPU, right? And you have an issue when you're using Unreal Engine, but also when you use Unity Engine in higher quality. So the gaming engines, they demand high computing power. And all of you know, the PCs and all this hardware in hospitals is just, it's bad, right? So, but you can stream this experience through the internet, so you don't need any hardware at all. So it's being calculated in the cloud, so it's on someone else's PC, but it's streaming through the net directly into your browser or even into the VR headset. So we are NVIDIA Inception partners, and NVIDIA is supporting us in integrating this, what is called OpenXR they have a framework that enables you to stream virtual reality experiences directly through the internet. So all you need is a headset, and it connects to that cloud server, and it streams the experience. And what I'm going to show you now is the environment. And as said, it's a combination. The Aimedis Avalon Metaverse is a combination of all of those technologies. Please let me know if you can see it. Okay, I hope.
Not yet.
Not yet, Michael.
Not yet?
Well, we can see a dark screen, which is interesting in itself. Ah, no, it is there.
Is it anyhow moving or not at all?
Well, not moving yet.
You see it moving now?
No.
Yeah, we
That's
do. It's a
unfortunate.
bit shaky. Welcome to WFNR.
Yes.
Yeah.
But I'm moving around. You don't see any movement at all, or it's very, very, very shaky, or is it okay?
It's shaky on my side.
Okay. Yeah, that's unfortunate. Unfortunately, in Zoom, the streaming is not so good. So what you see here is a map inside the Australian outback. So we want to catch the real environment. So not only the look and feel, but also the cultural aspects of virtual environments, so people can relate to what they see. And everything you see here is really 3D, so nothing's fake. There are no 2D elements. Everything you see, you can walk to, and you can experience this like it's a real virtual world, like a computer game, but with medical content. So for example, we have the WFNR area here, and on the other side, there's Avalon Outback Medical School. Well, we have, for example, to just give you a brief outlook, we have like virtual anatomy and physiology experiences, for example. That is not related to the WFNR thing now, but you can learn about cardiology and anatomy and all these things here. So what I want to say is everything is connected. So you have a real interactive world, and you can meet with up to a few hundred people onto these maps, and you can speak to them. You can exchange information with them. You can work together. You can go into a virtual training session, for example. You will meet AI avatars all over the map that you can speak to. Hello, you hear me? So you see, you can speak to the AI, and it is answering you. So we are training those AIs also to support people in performing the VR, AR exercises. So also in AR, you can have this AI guy standing in your living room, seeing it through the Apple Vision Pro, and speak to the AR, not only to get support in what you do, but also to capture data, to speak about how you feel when you do that. So you can even have like you can build scales of how you experiences that. So it's good for data gathering, and you don't have to click anything, you don't have to write down or have to type in something. You just speak to the AI, and the AI captures the information. And what you see here is one of the exercise rooms now. And you see those exercises, there's still a lot of room for improvements, but we are using meta-humans, and those meta-humans are being combined with the animations that we made with the physiotherapists. And the good thing is, you could say, okay, why not just doing YouTube videos? You can watch these exercises, how they have been correctly performed from every angle. So from the side, from the front, and then you can do this together with the avatar, and you can even copy a virtual copy of yourself next to this avatar, and you can see how do I perform compared to the avatar that is doing the exercise properly, because the exercise that you see is being performed by a physiotherapist, and next to it you can place yourself and compare how am I doing it, right? And there comes the data. At the moment, this is still in the first phase, so we have the exercises are quite rough, so we don't have finger movements. In the next version, it's also possible to have finger movements in 3D. So you can do really sophisticated exercises, and there's a perception of every finger and each hand and arm. You can already do it now with a full body motion suit. I think you guys know those suits from movies, right? Where you have all those things stick to your body and then you can record very, very sophisticated animations. We do this just with a smartphone, one smartphone in front of you, capturing your movements and translating it via AI into a animation. And that animation is directly translated live and in real time into this environment. So you can have live environments with animations and exercises using just one smartphone. So you see, this is the way it goes. And if you don't want to have that in the virtual environment, if you're not such a gaming guy, then you just can project those animations into your living room and you do those exercises at home. And we think that this is very promising because what we can deliver is neurorehabilitation to any spot in the world with a very low entry barrier, right? I mean, these VR and AR devices are all very good. No question. But especially when you go to countries in Africa, maybe they don't have VR devices, and especially they will not have an Apple Vision Pro. So you can just view those exercises on the smartphone, and everyone has a smartphone. And it even doesn't matter if it's a new one or an old Android smartphone, because you can stream the experience onto that smartphone, and then you can at least do the AI feedback and the training in 2D, even from your home, anywhere you are. And even you can give feedback and you can get in touch with us and you can get in touch with physiotherapists via the application and get a feedback. So we think that the outcome of certain neurologic conditions after a stroke, after a brain injury, a trauma, etc., will be much better because we don't lose time. We give people a direct possibility to start training effectively. And the more data we gather with that, the more sophisticated the exercises can be, and the more sophisticated the data will be that we gather with that. And yeah, so that is just a brief intro. I don't want to get too detailed. I said we have several maps with that. And we also have a platform I can show you. We have just a second. So what we do is also we have our own trained AI, which we call AVA. It's a medically trained AI, and it's feeded regularly with all kinds of guidelines, medical guidelines, cardiology, neurology, etc., and also with PubMed publications. So it knows exactly when you speak about those things. It's not just giving general answers like ChatGPT gives. I mean, ChatGPT has quite good answers in terms of some of these things, but most of the time it's very general. And our AI is very well trained towards all kinds of applications. For example, knows the 2024 ESC guidelines for atrial fibrillations and so on. So you can use the AI to really speak about the latest medical information and use it in combination with those exercises. So you say, okay, these and these things have that and that impact, and how am I performing? Can I relate to that with the things that I do? So we think that this will make a good impact. And I said, we are very happy to collaborate. I said, Melvyn would be happy to speak to you. And yeah, thank you very much.
Thanks, Michael. Just to make one point clear, the WFNR intention when we started this project is not therapeutical. It's educational. So we are not developing therapy tools, but we are designing tools for education of patients and especially caregivers and people in the surrounding of patients to give them an information what they can do. And what Michael already mentioned, I think for me, at least, and I'm an old guy and I'm not that familiar with all this decent technologies, but the most compelling factor is that you can approach an avatar in this environment and ask questions. Say, my father had a stroke 2 weeks ago, and he cannot move his right arm. And what sort of therapeutic interventions are possible? And the AI, in an interactive way, will give you decent and reasonable answers. We are just training the AI more with all available guidelines for stroke rehab, for MS rehab, Parkinson rehab, and whatever. So you have a complete interactive system which gives you more or less reasonable answers, which is quite different from just looking at videos. You can say, well, I'll show you some exercises on a video, right? But you cannot ask the avatar about certain elements of the training, how the training can be changed, improved, about how that has to be, let's say, adapted to the individual capacity of the patient and so forth. And this is very easily manageable with the AI behind it. I do not know how critical you are about AI applications. As usual in the advancement of science and technology, there are always pros and cons, and there are always dangers, and there are always chances. And my impression is that if it is used in a decent way, it can be extremely helpful, especially as an educative tool. You know, if people somewhere in India, in rural areas of India or sub-Saharan Africa or some areas of Latin America, they will never, ever have access to a classical rehabilitation environment. But using this, they are in a position that they can get all the information they need and to make that applicable to caregivers, maybe to physicians or even therapists down there somewhere, but even in the absence for home training. And I think that is for us, looking at the tremendous gap between available resources worldwide and the tremendous increasing need for doing that, is a possible way of bridging this gap. That was our intention. My impression at the moment is we're still at the, well, not midway, we're still before midway of this development, but nevertheless, it looks promising, and we will certainly follow this up.
Yeah.
So let's look at, Remco had a question.
Yeah, there was a question and a personal remark. First question: I love the emphasis of the accessibility for patients, but I'm interested in whether you thought about exploring the efficacy of 2D versus 3D delivery of rehabilitation. So is there anything maybe Michael or Melvyn can say about that?
So I think the clear answer is we don't know, right? Because we don't have objective data as of now in terms of outcomes, in terms of efficacy. But we think, of course, that the 3D delivery will be better, of course, because you have this immersiveness and you really understand movements from a different point of view. Because imagine you have, as I said, when you have a 2D video on YouTube, there are rehab videos on YouTube, right? And you can do some of those exercises, which is good, but you really cannot relate to your own body. And when you have this in your living room with an AR device and you have this person standing next to you and you can relate to their movements, we think that the quality and the efficacy is much better. But as said, this is yet to be proven.
Okay. Well, I have a personal remark as well. Yesterday, I visited the World Conference on ICT in Healthcare in Maastricht, and the big buzzword there was AI. Of course, Donald Trump and his friends have seamless, endless amounts of money available for the development of AI. But China is following up on AI pretty heavily. The Dutch computer industry, ASML, is blossoming because of AI. So AI and Europe needs to answer those big investments in all around the world as well. So yes, using AI for healthcare is interesting, and I believe that there's a lot of questions and a lot of debate. Is it safe? Is it sound? Is it any helpful? Is it just around the corner, or is it a promising technology for over 10 years? I'm not sure. But what you're doing here in this medical metaverse that you are creating is actually showing or demonstrating that it indeed can be very helpful and indeed can be very useful for those people who, as Volker says, have never access in the first place. So if it's that or nothing at all, I would always choose that. And although in the beginning the images on the screen were a bit shaky, I think all of us could see the enormous potential of this metaverse and what it could do and how it can develop over time, and especially if the investments in AI will only grow in the coming years, and the technology and the processing speed of our phones and so on will improve.
Yeah, as Professor Homberg stated, I think the most important impact this will make in training and education. Speaking about therapies, we have to do that later because we need to register those as tools and as has to have the approvals for that. But for education and training, this is outstanding. So what we also built at the moment is a virtual OSCE course together with Imperial College in London, where we train medical students. And the cool thing about this is they have this virtual environment. I will show you this briefly. Just give me 1 minute to show this. But because it also has an impact for the neurorehab part and for the training of physiotherapists and neurology specialists, you train the AI to know certain things, right? And then you train the AI to give you a feedback on questions you ask and even give you marks for what you said. So the AI can do basically an oral exam and you can have a real-time feedback. And not only that, the AI can then store this and you can have a graphic of how does my learning relate to that and how is that improving over time. So I think the possibilities are limitless. And now that China has released DeepSeek, which is open source and which is basically for free and also inexpensive in terms of the use of GPUs, we invested as a company a lot of money in NVIDIA GPUs, not only for the AI part, but mostly for the 3D part. So it's good investment because they're very performant. But it's good news because having all these things centralized and connected to very expensive hardware from a monopolist is a bad thing, especially in healthcare. We cannot work with that, right? Because what do we know how the prices will develop then? But if you have open source technology that relies on inexpensive and cheap and older hardware, even like it does with DeepSeek now, this is a very cool thing. And we are also going to integrate that into the system. And it's great. Imagine just 2 years ago, so 2 years and 2 months, I think it was December 2022 when ChatGPT was released. Compare that now to then. It's insane. And that is just 2 years, right? 2 years. And the next 2 years, we will be at a completely different level. When you take a look at this exponential growth this technology makes is insane. We cannot even imagine where we will be in 2 years. So this is so disruptive and so quick in terms of development. It will make all the things easier. It will even help like Melvyn, me, and all the others to develop those environments. We don't have to build this anymore by clicking the next version of Unreal Engine. You will tell, okay, build me an environment for rehabilitation, and this thing will build it for you. And then place an AI that does that and that and that, and the AI says, I know what I have to do. And you have it. You can even have personalized therapy experiences for each patient. And an AI agent, so you have an AI that is also something we develop, an AI agent that accompanies the patient, that knows him. He knows, hey, hi, how are you doing, Elizabeth? How are you doing since yesterday? You had a headache yesterday. How are you feeling today? The exercise yesterday was not so good. Let's do it again today. I think this can be a really brilliant experience. So let me just share my screen shortly.
Well, I think the world of medicine will tremendously change with AI. No doubt about it. When it comes to selection of therapies or the improvement of therapies, that will be a completely different world. There are dangers embedded into that, and we have to be careful about it. But basically, it opens a new world of chances.
Do you see my screen now?
Well,
yeah.
Okay,
yeah.
This is a virtual OSCE in the Dubai map. So this looks like Dubai, right? It's the desert next to the sea. And we have, for example, here an X-ray, interpreting a chest X-ray. So we have here this therapist, and you can speak to her. Hello, how are you?
Oh, wonderful to meet you. I'm doing quite well, preparing for my next lecture on interventional radiology techniques.
So we have several images here. So for example, we have that image, which all of you doctors know. This is a right lobe pneumonia over here, right? So this patient has an issue and we can speak to her. And can you tell me something about image number 2? This is pneumonia, right?
Ah, yes. Looking at this chest X-ray, we have a clear case of right-sided segmental pneumonia. I can see the classic consolidation pattern in the right middle lobe. Given the patient's symptoms, fever of 38.5 degrees Celsius, productive cough with yellow sputum, and shortness of breath, this radiological finding strongly supports our clinical diagnosis. As a radiologist with over 2 decades of experience, these are exactly the kind of cases I use to teach my residents at Avalon Medical School.
So you see, right? And when you're fed up with that, you can just go out and you can go somewhere else and you take a neuro rehab exercise, or you meet friends, or you take an anatomy lecture, or whatever you want to do. So we have also what we did, we have a cooperation with big pharma companies. For example, we did a big representation for Sanofi in France, which is also represented on this map. So you can go there, you can get information about pharma. You can do your own lectures, you can do your own training sessions. And this will have a big impact on neurorehabilitation and on neurology, but all kinds of other medical fields too. Yeah, that's it. Thank you very much.
Yeah, it will certainly have a major impact on the way of education we do today. And what you mentioned, eventually, if you have an alter ego AI assistant going with you in the medical world, that can be very helpful. But of course, there are inherent risks in this, right? I just downloaded this new Chinese app yesterday night, and then friends informed me that they control everything. And Volker, I tell you, they control everything. As soon as you use this app, yeah, you are in complete control of the Chinese government. I don't know if this is true. I haven't had any personal experience with it. You know, when ChatGPT was first published in the end of 22, early 23, we tried to play a lot with it. And my intention was for a while to cheat the system and ask questions they cannot answer. Most questions they could answer, and even when it came to neurologic rehabilitation, all the questions were a question I put were answered perfectly. I couldn't have done this better myself. But when you come to questions of why does Mona Lisa smile, for instance, then they had problems. And they were not trained in the history of arts to a sufficient extent. That's a problem, of course. It's not intelligence. It's the let's say administration of knowledge. What is going on with these systems? But in administration of knowledge, they are absolutely perfect. And consider a situation with a paucity of personnel we are faced almost everywhere in the world, in terms of physicians, therapists, nurses, whatever have you. This can be extremely helpful to augment the power of existing physicians or even replace physicians, right? And come to reasonable decisions. All of what evidence-based medicine, all this is making decisions on knowledge. And these systems are very knowledgeable, no doubt about this. And they are superb when it comes to reassembling knowledge and putting different aspects of knowledge together. I do not know if they are really inventive in the sense we would claim, which is an essential element of intelligence. We will see how this proceeds further. The great danger is that this connected to economy may give rise to new forms of government or exerting power which are beyond the boundaries of democracy. That is a problem, but this is a political problem. This is not a scientific problem.
Volker, we're drifting a little bit off topic. That's no problem at the end of the afternoon, but I think we could have an entire webinar on
Absolutely.
on artificial intelligence and politics and so on and so forth. But I think for now it's best if we wrap this up a little bit. First of all, by thanking our speakers. So Tom, Melvyn, and Michael, thank you very, very much for your wonderful insights and presentations. The video will be available on the websites on both the organizations, especially also XR4REHAB.org. I would like to invite you and all the listeners to a conference we're hosting in Lecco in Italy, end of June, and I promise to share the slide for that as well. Otherwise, my colleague Sylvia goes ballistic, so I would not dare to do that. But so there's a conference in Lecco on the use of extended reality in rehabilitation, not only neurorehabilitation, but on a broader sense. So please join us in Lecco. There's still so if you have a thing you want to present there, there's still we're still accepting contributions for that as well. So go to the XR4REHAB.org website and you'll find all about that. So I stopped this shameless promotion by thanking you, Volker, for the opportunity to address this topic to your community, the neuroscience community. So thank you very much.
Okay, thank you very much, Remco. It was a pleasure for this webinar. We will certainly go on with this, do it again in 6 months' time or so, and see if the further progress in this field. I may also thank all the speakers, the audience, and especially also our technicians who helped us to bring this and broadcast this worldwide. Thank you very, very much indeed. Have a good time. Take care. All the best. Thank you.
Thank you.
Thank you, Remco. Thank you, Volker. It was a pleasure.
Yeah. Well, and I come back to you on this false thing, because that really drives me crazy, because I think there could be good elements.
We were a bit unlucky with grant application on fall risk treatment for this particular application.
We stay in contact in this respect. Then.
Yeah, please.
Sure.
Thank you.
Okay. Remco, all the best.
Thank you.
My regards to
in my regards to Christina, thank you. And
thank you.
Talk to each other. Yeah, bye-bye.
Bye.